the first time stability nearly failed. There was a moment when everything Earth had built almost unraveled, not through sudden destruction, but through imbalance spreading quietly. Stability does not always break loudly. After the planet learned to regulate its internal power and atmosphere, Earth entered an era that appeared calm on the surface. This matters because danger does not always arrive as catastrophe. Sometimes it emerges slowly, through systems drifting just far enough out of alignment to threaten everything they support. The most insidious form of failure is the one that looks, from the outside, like continued success. As continents continued moving and recycling intensified, Earth's balance became more complex and more fragile. Carbon cycled between air, ocean, rock, but small shifts in that exchange began amplifying one another. Volcanic output increased slightly. Weathering slowed in places. Greenhouse gases lingered longer than before. None of these changes was dramatic on its own. Each fell within the range of normal variation, but their combined effect pushed the system in a single direction, and that directional drift, sustained over geological time, carried the potential to undo everything. Oceans responded first. Warmer waters held less dissolved gas, altering chemistry and circulation patterns that had remained stable for millions of years. Heat distributed unevenly, creating regions of extreme warmth alongside pockets of cooling. Climate stopped behaving predictably, even though no single force was responsible. The ocean's role as a planetary thermostat weakened precisely when it was needed most, as the thermal load on the surface increased beyond the pace at which deep circulation could redistribute it. Life, where it existed, felt the pressure. Ecosystems adapted to long-term stability now faced conditions that changed faster than expected. Extinctions began appearing not as sudden events, but as prolonged declines. The planet was drifting, not collapsing, but drifting was enough. Species that thrived under predictable conditions found those conditions shifting beneath them, not catastrophically, but persistently, in ways that eroded their capacity to sustain themselves over generations. This was the first time Earth discovered a dangerous truth. Balance could fail without breaking, and recovery would require more than patience. The planet stood at the edge of a test it did not yet recognize. As this imbalance deepened, Earth's feedback systems began working against one another instead of in harmony. Processes that once corrected excess now amplified it. Warmer temperatures reduced weathering rates in some regions, allowing carbon dioxide to accumulate further. Oceans absorb heat unevenly, weakening circulation patterns that had long distributed energy across the planet. The corrective mechanisms that had stabilized the planet for so long were not failing outright. They were being outpaced by the very imbalances they were supposed to correct. What made this moment especially dangerous was its subtlety. No single disaster announced a crisis. There was no global eruption, no massive impact, no instant collapse. Instead, small deviations compounded over long spans of time, pushing the planet toward thresholds that were easy to cross but difficult to reverse. The absence of a clear trigger made the danger harder to define and, in a sense, harder to resist. The planet could not respond to a threat it could not identify as a discrete event. Ice, once a stabilizing presence, began retreating in ways that accelerated warming. Darker surfaces absorbed more sunlight, reinforcing the trend. At the same time, biological systems struggled to adapt quickly enough, reducing their ability to regulate atmospheric composition. Life, which had become a stabilizing force, temporarily lost that role. The biosphere's contribution to chemical regulation depended on thriving ecosystems, and as those ecosystems weakened, their regulatory capacity diminished in a feedback loop that compounded the original imbalance. The build-up toward failure was slow, almost invisible. From a distance, Earth still looked alive, dynamic, and functional. But beneath that appearance, margins were shrinking. Systems had less room to absorb disturbance. Recovery took longer. Each shock left a deeper imprint. The planet's resilience, which had once seemed robust, revealed itself to be contingent on the continued alignment of multiple systems, none of which could compensate indefinitely for the failure of the others. This was the most dangerous kind of instability. Not collapse, but drift. Not destruction, but loss of control. Earth was approaching a point where correction would require intervention from forces larger than any single system. As Earth drifted closer to this threshold, the planet's usual corrective rhythms struggled to regain authority. Carbon lingered in the atmosphere longer than before, warming the surface just enough to weaken long-standing stabilizers. Weather patterns shifted gradually, but persistently, altering rainfall and erosion in ways that reduced the planet's ability to pull excess carbon back into stone. The weathering thermostat, which had served as one of the planet's most reliable regulatory mechanisms, was losing its effectiveness precisely because the conditions it was supposed to correct were undermining the processes on which it depended. Oceans, once reliable buffers, became strained. Warmer surface waters slowed deep circulation, limiting the transport of heat and nutrients that had regulated climate for ages. Stagnant zones expanded, chemistry changed, and biological productivity faltered in places where it had once thrived. The systems that once dampened extremes were losing efficiency. The ocean's capacity to absorb and redistribute energy diminished as its own internal dynamics were disrupted by the same warming it was supposed to moderate. This buildup marked the emotional peak of the crisis. Earth was not being overwhelmed by force, but by inertia. The longer imbalance persisted, the harder correction became. Feedback loops that once worked slowly now worked in the wrong direction, nudging the planet toward conditions it had narrowly avoided before. The crisis was not a battle between opposing forces. It was a gradual surrender of regulatory capacity, a slow dimming of the corrective mechanisms that had made stability possible. Yet even here, the planet was not powerless. Deep within the crust, tectonic motion continued. Volcanic output fluctuated. Weathering resumed where conditions allowed, and life adapted unevenly rather than disappearing outright. Earth had not lost its stabilizers. They were simply delayed. The deep geological processes that operated on the longest timescales continued working throughout the crisis, their slow but persistent influence eventually providing the foundation for recovery. This was the moment where failure and recovery stood closest together. A small shift, sustained long enough, could decide the outcome. The planet hovered in uncertainty, balanced between escalation and restraint. Earth was learning that stability was not permanent. It had to be reclaimed. The climax of this near failure was not a dramatic rescue, but a slow reassertion of balance from the planet's deepest systems. Correction did not arrive from the sky or the surface. It rose from below, carried by processes that never stopped working, even when their effects were delayed. Tectonic motion continued recycling carbon back into the interior, reducing atmospheric buildup over immense spans of time. Weathering resumed where climates allowed, pulling excess gases from the air grain by grain. Ocean circulation, weakened but not broken, slowly reorganized, restoring the transfer of heat and nutrients across the globe. Life adapted unevenly, retreating in some regions while expanding in others, preserving regulation where it could. The recovery was not coordinated. It was emergent, the product of many independent processes, each contributing their small corrective influence, until the cumulative effect shifted the trajectory. What saved Earth was not speed, but persistence. The planet did not snap back into equilibrium. It inched toward it. Every small correction mattered because it compounded. Over time, drift slowed, margins widened, systems regained room to absorb shock instead of amplifying it. Stability returned, not as a fixed state, but as a moving target held in place by effort. The resolution of this chapter reveals something essential about Earth's nature. Balance is not guaranteed by past success. It must be continuously rebuilt by interactions between rock, water, air, and life. Earth nearly failed not because its systems disappeared, but because they briefly fell out of sync. The lesson was that stability is not a condition achieved once and maintained passively. It is a process that requires continuous participation from every component of the planetary system. This moment changed the planet's future. It proved that survival depended not on perfection, but on the ability to recover coordination after it was lost. Earth did not avoid the edge. It learned how to step back from it. Sometimes the smallest shift in perspective becomes the beginning of a new future.